Okay, yeah. That was a great presentation earlier. I think it raised a lot of questions about kind of the security and like the determinism aspect of how we build AI agents. Um, so yeah, that's kind of what my talk is going to be about. If you notice that the title is a bit different from what was originally announced, I had to do a bit of like last minute refining to focus the talk a little bit more. But anyway, the theme of this talk is about like how you can take ambient agents to production with a couple of like these emergent CNCF projects. The previous generation of AI agents, just sat there and waited for you to just like interact with them. But like as AI agents become more autonomous, as we all know, stuff like proactively identifying at-risk orders, triaging incidents, opening PRs on their own, they're still waiting, like not for you to interact for them, but like they're waiting for it's kind of enough time to pass before they can interact and like check, hey, do I have more orders to check? So just checking like services and databases again. And this is basically polling, right? And polling's limitations were kind of solved a long time ago by the cloud native community, even before agents came around. So today I really want to hone in on like two major areas, which is one, how to build ambient AI agents, which are agents that can sense or react to changes before they happen without polling. And the second is like how to build AI or ambient agents that can be reliable enough to be trusted in production. So a bit about me, I'm Jeffrey, I'm a CS student at UBC, and I'm part of like Google Summer of Code at CNCF. And I'm working on these two projects. One is Drazzi, and then one is Dapper Agents. So before we begin, can I get like a show of hands? Like, has anyone heard of these projects before? Like, Dapper? Got a Dapper user here. Got another. Is it Dapper or Drazzi?
Yeah.
Okay. So a couple of you, but I hope like everyone can take away at least something from this talk. So here's a list of the topics, but for the sake of time, we'll just dive right into the content. So we briefly touched upon the fact that many agents today use polling to detect changes, but what exactly are the limitations of polling? Well, for one, it can't detect the absence of change. So I'm talking about stuff that should have happened, but haven't yet for some reason. So let's say you wanted an agent to escalate when an order has been stuck processing for 15 minutes. Like, how would you do that? Well, you need to like keep track of state on the application side, but this is now problematic because, well, you have to do that yourself, right? Stuff like when was the last change and when did the last change occur? And polling can also miss certain changes, especially when you're dealing like with sub-second timescales. Like for example, you can see in the diagram above, if you wanted an agent to detect a burst of credit card charges and like kind of signal that for potential fraud, you need to be able to detect changes that are very close together in time. But to catch that with polling, you need to poll at an extremely high frequency. Like at a sub-second level, you all know that network latency is a pretty big issue. So it might be just physically impossible for that request to arrive before the change, like just disappears and you don't detect it. And even if that is possible, it places a bunch of burden on the services. It doesn't really scale well. And these issues are there no matter if the customer is an agent, like a browser, a user, or another service. And that's kind of what led to the emergence of event-driven architectures in the past. But agents are unique in the sense that they are capable of very open-ended, non-deterministic tasks, and they need a lot of information and context, right, to be able to do what they have to do. And this is stuff that maybe existing services or third-party providers may not provide. And that is really where like a change-driven architecture is advantageous. Like agents are triggered by your data sources. And the context can basically consist of everything that your data has to offer. But naive change-driven approaches don't really work. Like if you have relational data that sits in your database, right? Raw changes are like insert events, update events, delete events. And because like relations are like normalized, a change that's detected by the agent would be on every row that's inserted, on every order row that's inserted, on every transaction row that's updated. And these are not really actionable tasks for the agent because, well, they're like really low level. So in order to kind of have action, we need to be able to pull in changes from different sources and process them into higher level sort of what we call business events that an agent can use. So something like an order delayed event with order, transaction, customer details. But building a system that does this is really difficult, or it can be difficult without expertise. So if you're a smaller team or an individual, it can be pretty hard. Some of you may be familiar with like stream processing, which does kind of the similar task, but that's also like a massive operational burden. So what if we had a solution that does all that processing for us? So even you as an individual who might have like a varying level of expertise, they can build change-driven systems and use them to power AI agents. And that is where this project, Drazzi, comes in. So it's a CNCF project. It's a Sandbox project that came out, I think, about a year and maybe a half ago. And it kind of abstracts away that operational burden for you. So you can build systems, including agents, that can react to changes across like different data sources. It has multiple deployment models. So there's, I think, 3 right now. It comes as like a Rust library if you want to kind of deploy it on the edge or like in embedded environments. It comes as a binary if you want to try it out and self-host it. And it also comes like you can run it in your Kubernetes cluster with its own control plane. Its architecture is designed to be like declarative and sort of extensible. So there are many pre-built connectors right now, but if you want to like build your own connector or contribute to it, or a solution that other people can use, you can basically do so with one of these like language SDKs. So there's like one for Python, one for JS, TS, and then one for C#.NET. And I'll basically just jump into a little bit about Drazzi's architectures. And it's quite simple, actually. At a high level, it consists of 3 main pieces. The first is sources, which are essentially our input connectors. And a source can be really anything that has a change feed. So these are things like databases, streaming platforms. It can be like GitHub, Kubernetes, and much more. So if we look at the diagram above, we can use whatever existing mechanism is offered by any sort of source to get changes. So for Postgres, we can use its replication log. And for Kubernetes, it has like this wash API that we can use to get changes. The second piece is queries, and this is where like the magic really happens. Like in a single graph query, you can define a business condition that an agent can act on across all your different data sources in a way that would normally be kind of impossible to do. Like, for example, you can't really do a join across Postgres and MySQL normally, but with a Drazzi query, you can do so. And it supports 2 standard languages, OpenCipher and GQL. A typical graph query is like a snapshot or a SQL query. You can only really see what your data is at a single point in time, which is fairly limiting. But what Drazzi does is that it maintains query state, and then it takes these low-level changes, and then these changes feed into these queries, which then kind of maintain state, and then they just continue to evaluate using those change events against the current query state so that your query is always up to date. And then if your condition that you define in your query is satisfied, it emits an event in the shape defined by your query. So you can see like kind of how queries fit in. So once that business event is emitted, it has to go somewhere, obviously, so you can take action. And that responsibility is handled by reactions or output connectors. So we can take a lot of different actions with these reactions. So in our diagram, we have a event grid reaction, which is like a managed pub sub service. So you can power a bunch of workflows, a bunch of serverless functions. There's also like a signal R reaction where you can like power dashboards live. And we have like a kubectl reaction where essentially you can create a little bit of a rudimentary Kubernetes controller, but it basically just executes kubectl commands for you. So let's take a look at like a concrete example of how sort of Drazzi's configuration works, just to see how you can build these. So imagine that you're like operating a car rental business, and you want to be able to notify customers like when their vehicles are ready. Hey, pick these vehicles up. But you're building from scratch, so you don't have anything to build off of. But what you do have are the vehicles that are sitting in this like MySQL database, and an orders relation that's sitting in a Postgres database. So for vehicles, what we're doing here is we're creating this sort of source manifest. And for orders, we have this Postgres manifest. And we're basically providing the connection details, which tells Drazzi like how we should get the change events. And then we have the relations, just basically specifying what relations that we want. So next is sort of the delivery ready query, which is our business condition. I've kind of split this up into two parts, just so you can see better. So this first part is basically defining the relations that we specified earlier in our source. And then we also have, oops, forgot to click. We also have our joins, so our relation that we can use in our query. And then the query itself is basically a graph query. So it says for any order, we want to emit event that only occurs when an order is ready and the corresponding vehicle is near the customer's location. So you can see like in the where clause, that's kind of what that where clause means. And then the event should have this shape that's specified by the return clause. So you can see it has like the order ID, the order status, the vehicle information, and like a ready timestamp. Oops. Drazzi has a bunch of like built-in functions that you can use for like aggregation, for timestamps, and defining conditions across time. So like if you wanted to sort of detect if a condition is true, like if it has been true for X amount of seconds, you can do so with Drazzi's built-in functions. So for the ready timestamp, we're basically saying, okay, we want to take the timestamp to be the time when this whole condition evaluated to true. So we're just taking the max of the orders relation and then the max of the change for the vehicles relation. And then for the reaction, we might want dashboards that we want to be able to track these sort of ready conditions live. So we have a reaction to send these events over signal R. So we specified the queries that we want our dashboards to have. And basically once we like apply these manifests, we are pretty much good to go, and we have like a working end-to-end change detection system. So that's how we can detect changes, but how can we build an agent that can wake up on these changes? But like the building part is not that difficult, right? Like there's a bunch of agent frameworks nowadays that have popped up that kind of extract these sort of concerns that you as a developer can use to build agents. We have LangChain, LangGraph Deep Agents, OpenAI and Anthropic SDKs, like Microsoft Agent Framework, Strands, a bunch of these frameworks. But when we're talking about moving sort of agents from demos to production, especially in like high stakes regulated environments and scaling them up, there's a few limitations that we've kind of encountered. And this goes back to the idea of like ambient agents, right? Like agents that need to wake up in reaction to certain conditions. They're running in the background, and they will only require intervention occasionally. But we still need to have the peace of mind that they will be able to complete their tasks, even if the environment itself is unstable or unreliable, whether it's like on the cloud, on-prem, or hybrid. So like if a service has an outage or like a solar flare bricks the machine that you're on, like these issues will happen, and we kind of want to be able to make these agents resilient to them. And then of course there's like a whole host of other factors to consider, like security, compliance, auditability on top of that. And that's kind of what's missing in like today's agent frameworks. They're sort of agent first. Like execution itself is not really a main concern. So what this means is that if an agent is running for like 100 turns, and then on turn 70 it crashes, then if you're running like 1,000 agents in parallel, you have to repeat like thousands of expensive LLM calls, tool calls, and of course going back to that determinism thing, their outcomes might not be the same because agents are just non-deterministic. The second thing is that they're not easily scalable, right? If you want to run thousands or even millions of agents concurrently, and to be able to run them on a single machine, even on the single core, there are certain limitations to that. And that kind of relates to our third point, which is cost effectiveness. With millions of agents on like a single machine, you might find that a bunch of them are just going to be idle, right? They're waiting for external approval. And we want to be able to free up those resources so other agents can run on that machine. The fourth thing is that they're missing some out-of-the-box security measures that we have to implement ourselves. So if a malicious actor goes in and modifies the agent history, how do we detect that so we don't for auditability concerns? Agents are also going to be acting like on behalf of users and maybe even across organizational boundaries. That's kind of maybe the direction that it's going. So we need to be able to identify those agents, right? And the fifth thing is that developer experience is a little bit lacking. In order to interact with other services, publish messages, read and write from state, call other services by different protocols, HTTP, gRPC, having the agents be triggered by events. You need to do that reliably, securely, and in sort of a decoupled way that helps you develop faster. And there's also this issue of having to switch from like a development environment to production environment. And in order to do that, you might need to make some changes to your code, right? So depending on what you're doing, you may need to, let's say you use a remote workspace. And all this prevents you from focusing on actually shipping agents, which is the thing that you want to do. So this is really where kind of a Dapper Agents comes into play, which is a framework that kind of prevents you from having to bolt on a bunch of different infrastructure on top of your agent framework. So it gives you like a durable execution engine. It gives like an agent runtime, like a serve authority, so you can focus on just writing, developing your agents. Dapper Agents is a framework that provides a harness for agents, and it, of course, has abstractions for developer building agents. And it's built on top of Dapper, CNCF graduated project, which, as I mentioned, gives that sort of durable execution, agent runtime that makes the agents reliable. So its benefits are, yes, it's open source, vendor neutral, cloud native, yada, yada, yada. But more importantly, it sort of addresses the gaps that we mentioned earlier. You get the inherent durability as it's built off of Dapper workflow engine. We treat agents essentially as a workflow. And the workflows themselves are orchestrated by the Dapper sidecar. So you don't need that heavy, centralized durable execution server that some of existing offerings have today. It scales quite well horizontally and vertically to the point where you can have millions of agents on a single core and run millions of agents concurrently across tons of nodes. And this is thanks to the actor pattern that Dapper employs. And also it can scale to 0 thanks to the actor pattern as well. If you need to tick off checkboxes for compliance, the Dapper runtime can sign the agent and workflow history. And the Dapper control plane also has this certificate authority that can sort of give agent apps an identity. This uses the SPIFFE standard, which is another CNCF project, but I won't go into too much detail because that's a whole other thing that I don't have a lot of expertise in. But these are just 2 examples, since there's a lot more that Dapper offers. And lastly, because it's built off of Dapper, it benefits from the Dapper APIs. So you can swap LLM providers, you can publish messages, call the services, which may be agents, which I'll just get to in a second. So as a quick aside, I'll just quickly cover what Dapper is and what it brings. Dapper provides APIs and sort of building blocks that help you develop microservices and distributed systems, including agents. Because in some sense, you can think of agents as like this very tiny stateful microservice, especially on the cloud. So what the Dapper community found out is that a lot of these APIs and building blocks can be composed together to build agents. Dapper stands for the distributed application runtime. As I mentioned earlier, it's a CNCF graduated project. And it sort of sits in between your application layer and the sort of infrastructure layer. And it runs as a sidecar next to your apps. So for Kubernetes, let's say you deployed like a pod and you have an app, the Dapper sidecar just sits as a container next to your sort of app or your workload. Like Drazzi, it supports multiple deployment models. It comes as a binary, so you can like mess around and self-host it or use it for development. And you can run it on Kubernetes, of course, with its own control plane. And really the main advantage of Dapper is that its APIs are agnostic to whatever the underlying implementation is. And you can swap providers out at runtime via Dapper components, which is just configuration. So because we're talking about agents, let's use the conversation API, for example. The conversation API basically provides a generic interface for conversing with LLMs. So in development, you can choose a tiny model that you can maybe run on your laptop, host that locally with a Llama. And then in production, you can swap it for a more expensive, like high reasoning, like a Claude or like a GPT model without any changes to application code. And so there's a bunch of other like APIs as well. You can see kind of some of the providers for that. But for the sake of time, we'll just move on. Here's some stats about the community. There's quite a few contributors, has a bunch of stars. Yeah, there's a reasonably thriving Discord as well. If you want to join, there are a couple links that I'll have later. There's a few companies that contribute to it. There's some big ones there. And there are also quite a few end users as well that use it both internally and in production. So these slides are quite old, but there's definitely many more that use Dapper. So now you know what Drazzi and sort of Dapper can do. Let's talk about the focus about sort of the GSOC project that I'm doing right now. We're basically trying to build integrations that can help developers build ambient agents, like I mentioned. We have one integration that will be released pretty soon, allowing you to subscribe to a Drazzi query from a Dapper agent in a single line of code. So the agents can just immediately start reacting to changes. And before you needed to sort of write a ton of boilerplate, make custom modifications to agents, and sort of really delve into what Dapper agents and Drazzi has to offer. So you have to read the docs and like understand their sort of principles. So the integration tries to reduce that learning curve, so you really just have to kind of look at a one-page of doc and then just apply that. So if you're interested, you can read a blog post about the work we've done so far on my site. Link is up there. So I actually have a demo video. Unfortunately, it isn't live because my mentor sort of advised me not to try like a live demo because my luck is going to break. So it's just going to try and show you how to build an ambient agent today with the integration that I mentioned. Link to the example is up there if you want to try it for yourself later. So just for a bit of context, like in this scenario, we're kind of imagining that we're like an electronics retailer, and we're managing inventory. So we already have a bunch of existing infrastructure, as is probably the case. And what we want is like an agent that can sort of run in the background and process or sort of restock on items when they're out so that we can focus on like more pressing matters. So let's see if this video works. What the heck? About that. All right. my note just went away. Let me see. Okay. Okay, you know what? I'll just like remove them for now. Okay. What the fuck? Why is it so hard? Okay. I pause it. Okay. And then I full screen. Okay. So yeah, basically I've already kind of set up the sort of infrastructure. I'll just walk you through it really quickly. What the hell? Okay. Maybe I'll just have to press space. Do this. Nope. Okay, what if I just click it instead? Okay, you know, I'll just have it like this. So yeah, basically listing out all the pods in the sort of Dapper namespace. So you can see there's a bunch of services there. These are the services in the Drasi namespace. So that's sort of Drazi's control plane. And then this is our sort of existing workloads. We have an inventory agent, we have Postgres and Redis, and we have like a workflow dashboard. So here are sort of the Drasi manifests. We have a Postgres source that's pointing to our existing products. So I'm just showing like the credentials and all that. And then this is our query. So we're basically saying that if a query or a product has a stock that's below some threshold, that's a low stock product. And then if a product has completely no stock, that's sort of a critical stock event that should be emitted. We also have our sort of reaction, which just publishes events for our two queries to a pub subtopic or two pub subtopics. So we just configure that there. And then because Drasi, or the pub sub reaction uses Dapper, we just have a component that points to our Redis. So we can use Redis streams for that. And then this is our sort of Postgres configuration. We have a products table with some product information. We have the current sort of inventory level, and then our sort of threshold where that would be sort of low stock. And then we have a few products, sort of low stock products. I think that's what I'm trying to do. All right, so you can see like the two numbers on the end. So these are the low stock products, and then I'm highlighting now the sort of critical stock products, the products that are out of stock. And then here are the sort of the Dapper components for our inventory agent app. So we're just using our Redis. That's sort of like the durable state component. And then here's our sort of agent using Dapper Agents. We have a bunch of instructions. We have our components defined. And then we're just wiring the components in to our agent. Okay, stop highlighting. Okay. Yeah, so, and this is basically the app itself. So we have a task. It's basically outputting a purchase order. And then if you notice that, that's basically our extension right there. So it's basically a one-liner that you can use to sort of subscribe to Drasi queries. And then we have a deployment for the inventory agent, all the good stuff. And then we just have some annotations that tell Dapper, hey, inject the sidecar into a pod. And then that's just like the workflow dashboard. So if we load it up, we'll see that we have no executions yet, which makes sense because we haven't brought up the Drasi services yet. Okay, bro, what am I doing? Okay. I think what I'm doing now is, what? Okay. So this is basically the Drazzi VS Code extension, which is just a more user-friendly interface for bringing up sort of Drazzi components. So right now I'm applying the Drazzi source that we have earlier. It's going to take some time. Any day now. Still going. Okay, there we go. It's green, and then we should be able to check that. All right, those are also the internal services that Drazzi uses. And then now we're applying our queries. So these should be much faster, yep. And they're already done. And then, yep, those are basically the query services. And then lastly, we're applying our pub/sub reaction. And this shouldn't take too long either. All right, it's good. And then you'll see on the right, basically the workflows were triggered pretty much immediately because we already had our sort of products that satisfied our query conditions earlier. So you can see we have our, what is this product? Like a RAM kit. We have our like SSD. That was out of stock, I think. And these are our sort of low stock events. I'm not sure what this is, like a AI sleep mask. It's like a tablet. And then finally we have, what is this, like a PC. Okay. So now I think what we're going to do is basically try and insert some data and see how like sort of source data changes can trigger these sort of agent runs. So I'm already connected to the Postgres instance, and I'm going to be adjusting the stock level to, I think, was it 3? There we go. And then now we're just applying the change, and then the agent run should occur. The agent should pick it up. There we go. And then you can just see it triggered like a low stock query, and then the agent just picked it up. Next, I think we're going to try out the critical stock query. So we're going to set the keyboard stock to 0, and then apply that. Boom, the workflow occurred. And then we see, yep, we have all the payload and everything there. And then lastly, we're just gonna try and adjust the stock level so that it shouldn't trigger the query, so just like a normal change. See what happens. So refreshing there, and you see that basically the agent didn't pick it up because there was no event in the first place. I think that's everything, actually, yeah. So I can bring up the notes again. Interview, skip. Okay, that's basically it for the demo. Now I'll just give a sort of brief overview of what we're going to be doing next for the project. So the first thing is like we want to make these queries discoverable via like MCP. So basically expose them as MCP tools. So the agent can basically create subscriptions at runtime. And this is either sort of dynamic, or even you could be able to potentially intervene and create these queries. So we're basically just building a new Drazzi reaction with an MCP server. And the second thing is that we want to be able to scale the agent workloads to 0. So we mentioned earlier that the sort of agent actors themselves were able to be scaled to 0. And we want to be able to apply that to workloads. And this is useful in the case if like agents are waiting for a really long time, potentially over the span of multiple days. In that case, we want to scale the workloads down to 0 so we don't sort of waste resources. To solve this, we can use autoscalers like Kata. So we can dynamically scale them. And then when like a meaningful change occurs, when Drazzi sort of emits event, we can scale back up the Dapper agent apps, and then basically sort of be able to handle the events. So pretty much, that's it. We have some time for Q&A. In the meantime, I'll just leave my links and sort of Drasi and Dapper links. So I'll just open the floor to questions. Yeah, I'll start with you.
Hold on.
Yeah.
Great presentation.
Yeah.
And thanks for introducing Drasi. So I have a few questions around Drasi. So what I understand is a data change platform to track, right? Now my question is around how does it track? Does it track at the data level or at the metadata level of the table? Like at the columns or at the entire table? I'll give you a bit of a context why I'm asking this.
Yeah.
So on a day-to-day basis, I work with multiple tables which are really huge, like in terabytes. One of the challenge we are facing is track changes to build similar polling queries, alerting systems and all.
Yeah.
It's very, very resource intensive to query, or not even query, like queries afterwards, but to track there is a change to trigger a flow. Now, what I'm trying to understand is Drasi, how does it work under the hoods? Is it at the column level it tracks, or is it continuously tracking that table? But it's still going to consume resources, right? So what is under the scene? How does it work internally?
So I think for like a really in-depth example, you could probably ask the maintainers themselves, but from what I understand, Drazzi sort of has, so the queries, right? You have the queries at a high level, they sort of track query changes, but under the hood, it sort of maintains this graph index. So when the source change events, so for like the relational example, it would be sort of row level changes. And when the query starts up, it bootstraps itself. So it sort of gets a snapshot of the state of the sort of relation. So I guess in a case where you have like millions of rows, like a lot of data, you have to consider like sort of a cost benefit, like, Drazzi could work for that, but it just depends on the query that you're trying to achieve. So
thanks for that. Do you consider Drasi as a data quality management tool? Like there are a lot of EQM outside in the market. Would you consider Drasi as part of a data quality management tool, or that's a completely different?
I'm not familiar with that term exactly.
Okay, I'll check it out as well. I'm definitely interested, and thanks for introducing Drasi. I didn't know about this tool. It might work out for us, I don't know.
Yeah, it's like sort of like a different sort of architecture. Instead of like stream processing, you just kind of work with it at a higher level and track changes in the sources without having to build it yourself. But again, your use case might vary. So,
any other question? Okay, I have one here.
So my question is about Drazzi.
Yeah.
It does a few different things, and I feel like one of them is state management plus kind of return output. What's the difference between this and Zod schemas and Zod in general? That's one question. And second is why data-driven event system? Like, what if I have a system that requires no data, but I still need the agent to output something? Incognito workflows, right?
Okay. Yeah, so the first question was why not Zod, right?
Yeah, what's the difference between Drazzi and Zod?
So Zod is, you mean like the TypeScript sort of data validation library?
Yeah, it's as in your example, you had an input and then the return, which you specify what
Yeah.
the return is, right?
I think there is still like a benefit to doing that on sort of the client side, of course. But like really with Drazzi, the idea is that you have everything like config based, so you can like switch it out. And maybe you have a team that's like on the Drazzi side, define the queries, and you define your API contract, and then you, as the app developer, might be worth. You could use Zod if you're building with that. What's the second question?
Why data-driven actions? Why not, event-driven, which is like any type of message? Webhook events, you have SQS event if you're on AWS. Why data-driven? What if I have an event that doesn't involve any data manipulation or changes?
Like in some sense, it's kind of like a hybrid. So yes, you have reactions that can produce events. Like there's like a HTTP reaction that can sort of trigger a webhook. But again, it's really sort of focused on the sort of data change aspect. So like if the data doesn't change, well, you can detect like queries for which like kind of is that span over like a period of time. I think there are like capabilities that Drazzi can do, but again, like it's sort of targeted at the specific sort of source data change sort of mechanism. So yeah, it is event-driven in a sense, but it's also change-driven. Sorry if that didn't really answer your question.
No, that's okay. Thank you.
Hello. So I have some questions about Drazzi.
Yeah.
So I kind of understand that you're trying to put an agent and it's supposed to have like a system where you can understand events that are coming in. The question is, why not just use algorithms for a lot of those cases? Why need an agent? Because a lot of times what you want is a simple and deterministic output. And it's kind of a question of, okay, what does agent bring that is worthwhile?
So you mean like, I think the agent is focusing more on Dapper agents, right? And Dapper sort of agents does offer like workflow capabilities where you can sort of chain together LLM calls or your agents together in more of a deterministic manner. So it does offer like APIs for that. So again, it just depends on your use case. Yeah, in some cases, for more creative tasks, you might want Drazzi and Dapper agents. Sort of the agent itself has like to be able to be triggered. But for more deterministic sort of actions, you could use a workflow instead.
I had a similar question.
Yeah.
Yes. So in your example, you had agent that it basically, if we have low stocks, we create new, order or ticket for some. Do you have any other examples of real world when it actually can be helpful and cannot be replaced with basic if-else deterministic workflow?
Let me try and think. Well, I think the main issue is I don't have a ton of industry experience, so I haven't really worked with it personally, but I guess maybe I'll think about it and I'll come back to you after.
Awesome. Any other questions? Are we good? Perfect. Okay. Thank you so much, Jeffrey. Everyone,